We begin studying Unit 5 with important segments in triangles. Here we're talking about a midsegment of a triangle is a segment in a triangle that connects the midpoints of two sides. The midsegment theorem says the segment containing the midpoints of two sides of a triangle is parallel to the third side and half as long as that side. So if we have a triangle, it can be any kind of triangle, and we have the midpoint of two sides of that triangle, say that this is the midpoint of this one and that this is the midpoint of this other one. And let me move that because it doesn't look like it's in a good spot. There we go. Then the line that connects them will be parallel to the third side of the triangle. So this line here will be parallel to this side, and it will be half its length. So if this is x, this one is 2x. And that's important for solving problems that we'll see. Equidistant, a point is equidistant from two figures if it's the same distance from each figure. Concurrent lines, three or more lines that intersect at a single point. So some of these special segments and triangles are going to be concurrent, where we're going to draw three of them and they will meet at a particular point. The point of concurrency is the point of intersection of these three lines. So right here, you can see these three lines intersect at point P. A median of a triangle is a segment from the vertex to the midpoint of the opposite side. And here's a picture. It goes from the vertex to the midpoint of the opposite side. An altitude of a triangle is a perpendicular segment from the vertex to the line containing the opposite side. Can be inside, outside, or on the triangle. If we have an obtuse triangle, the altitude will be outside if it's coming like this from this angle here. The altitude from this angle, would just be inside of that triangle, but it can be outside of the triangle in an obtuse. In an acute triangle, it will be inside. This might possibly be a right triangle as well. And then on a right triangle, the altitudes, two of them will be on the triangle because they're going to go down the legs of that right triangle. These are two altitudes of this triangle. The other one would go through the middle of it. Perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So any point on this line XM is the same distance from A as it is from B. Says what is the perpendicular bisector considered in regard to points A and B? It's considered an altitude, like a height. If you were to connect the dots, you'd have a triangle and that would be the altitude of it. The converse of the perpendicular bisector theorem says if a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector of the segment. So if we know that the distance from X to A was the same as X to B, which is what it says here in our given, then we would know that XM is the perpendicular bisector of AB.